Hello and welcome back SciTi Tech. In this video I'm going to show you how to add dimming LEDs to your trinocular microscope with using a Tip122 Darlington transistor circuit that controls the dimming of the LEDs. So that way you can be able to use above lighting instead of using the below lighting that is inside of every standard microscope. So that way you can use something, for example, like an Arduino Uno, which covers the below lighting. And that way you can turn on the above lighting and you can be able to see the Arduino Uno with the microscope. Let's get started. And these are the items you're going to need to make for this project. The items you're going to need: a perfboard, a 1N4007 rectifier diode, a Tip122 Darlington transistor, a washer, nut, and knob, which will go to the 10K ohm potentiometer. You're also going to need a female DC input power jack, which will go to a 12 volt LED strand. And this is the schematic that you're going to need to follow to make for this circuit. Now let's go ahead and assemble this project and let's get started. First, I need to solder tin these pads that is on the perf board. Solder tin them just like this. Next, take the 10K ohm potentiometer, put it in this orientation, solder it to the solder tin pads, and there we go, stuck in place. And now add some more solder to secure it in place better. And there, the potentiometer is now secure into place. Next, take the transistor and place it into the perf board, and bend the leads just like this. Take the transistor and put it into place, and I want to take the emitter and put it into the hole, and the base and collector over to the potentiometer. The base will connect to the center pin of the potentiometer, and the collector will connect to the other pin of the potentiometer. Put it into place just like this. Bend the leads just a little bit, and now take the heatsink of the transistor and solder it to the perf board. Next, solder the base of the transistor over to the center pin of the potentiometer, and then solder the collector to the right pin of the potentiometer. Press down the leads and resolder them to make sure they stay in place better. And there, it is now soldered into place. Next, solder the emitter of the transistor. Next, take the rectifier diode and bend the lead of the anode, and then keep the lead of the cathode straight. Take the anode and put it into the perf board, and then solder the cathode to the left pin of the potentiometer, and then solder the anode into place. Next, take the female DC power jack. This wire is a negative. I want to connect that to the cathode of the rectifier diode, and then the positive wire over to the collector of the transistor. Take the negative and put it into place. And something I've never done before is put it into the potentiometer. Solder it into place. And the interesting thing is it solders into place very well. And I'll do the same thing with the positive wire. And then put it into the hole of the potentiometer, which connects to the collector of the transistor. Solder it into place. And there, the two wires are now soldered into place. Next, I'm going to take the 12 volt LED strip, and I want to take the wires and put them into the perf board. Clamp it down, and I'll solder it into place. Next, take the anode of the rectifier diode and connect to the negative of the LEDs and the emitter of the transistor over to the positive of the LEDs. Bend the anode over to the negative, and I'll take the excess wire and bend it over to hold it into place. And now, solder it into place. Cut off the excess, and there, it should look just like this. Next, I'm going to take this wire and connect the emitter over to the positive of the LEDs. soldered into place, and there, the circuit is now complete. Let's go ahead and test it out. And I'll take this DC power jack that is connected to the 12-volt power supply and connect it into the circuit. Plug it in just like this. Turn the potentiometer, which will then turn on the LEDs. Right now, it's on off. Turn it up and we'll turn on the LEDs on maximum. And as you can see, I can turn the potentiometer and adjust the brightness. And as you can see, it works. Next, take these clippers and cut off the excess of the perf board. And there, should look just like this. Next, clean up the circuit and cut off the excess leads. And there, this looks a lot better. Figure out the best position to place the circuit onto the microscope so that way I can be able to put it on permanently. This position looks the best because I can take the LEDs and wrap it around and attach it to the microscope. And the DC jack connects downwards like this, which is perfect to plug in, and the potentiometer is easy to access. Everything's figured out, and now I need to create the housing for the circuit. I could 3D print it, but I don't really want to do that. I want to do it simple where I take some electrical tape and wrap it around. And I'll take the electrical tape and wrap it around the circuit. Doing this will keep everything properly insulated. And there, it should look just like this. And now take the circuit and place it onto the microscope. And now I figured out this position is actually the best and most comfortable. Place it in carefully. Take a mark and mark it so that way I know where to glue it into place. Take some hot glue and put it onto the housing of the circuit. Hold it into place and wait for it to solidify. Next, take some really strong duct tape and duct tape it into place because the hot glue isn't very reliable. Cut the sides a little bit and bend over the duct tape, and there, it stays in place. Next, take the LEDs, place them over. Remove this paper, which will reveal the sticky adhesive that is on the LEDs. Bring it over, stick it into place, and have it go across just like this. Doing this will spread the light more evenly. As you can see, I took some hot glue and glued down the LEDs just to make sure it stays in place better. And there, this part of the project is now complete. Now let's go ahead and plug it in and test it out. And as you can see, it works. Very nice and very bright. And now let's see how this works by taking an Arduino Uno and put it into the microscope. Placing it on just like this. And as you can see, the top of the Arduino Uno is now lit up, which means the bottom light of the microscope isn't necessary. And of course, this microscope still functions as a microscope because of the bottom light of the microscope still lights up, allowing me to take glass slides and place them onto the microscope and use it as a microscope with the light shining from underneath. But if I were to take something that is thick, like say a circuit board or an Arduino Uno for example, the bottom light doesn't shine through very well, which makes it very useless, which means you can't see anything on top of the circuit because the light from underneath is only shining from underneath. So now I can have the light that is shining from above, which means I can be able to see from above, and I can also adjust the brightness. And now let's go ahead and test this out, and let's see how this looks in the microscope. As you can see, this looks very interesting in the microscope. I never thought it would look like this. There's actually a lot of dust on this Arduino Uno. That's very interesting. Didn't really see that with my own eyes, but I can see it in the microscope. How very interesting. And you can see all the components up close, which looks very cool, and you can see the detail of the solder. This is actually very useful if you want to be able to see different objects that the bottom light can't shine through, or objects that you want to see the surface of only, which is very interesting and very useful. And there you have it. Now you know how to add a dimming LED circuit with using a Tip122 Darlington transistor. Thank you for watching Side High Tech. I hope you learned something new, and don't forget to like, share, and subscribe, and of course click on the bell icon to be notified of future Side High Tech videos. Till the next tech, goodbye.